Welcome to Ask and Learn.
We were asked to answer a question about finances using recurrence relations. So we're told that the deposit of $100,000 is made to an investment fund at the beginning of a year. We're told on the last day of each year, 2 dividends are awarded. We're told the first dividend is 20% of the amount in the account during that year, and the second dividend is 45% of the amount in the account in the previous year. In Part A, we're asked to find a recurrence relation for Pn, where Pn is the amount in the account at the end of n years if no money is ever withdrawn. So you have the Pn amount in account with no money withdrawn. And this is after n years. So in the first case, we have that the amount in the account at the end of n years is the amount that was in the account at the end of the previous year. Which is going to be Pn minus 1. And in the second case, we have that the first dividend is 20% of the amount in the account during that year. And the amount in the account during that year is Pn minus 1, the same as the amount at the end of last year. And so the first dividend is going to be 20% of Pn minus 1, which is 0.2 Pn minus 1. And now in the second case, third case, we have that the second dividend is 45% of the amount in the account during the previous year. And the amount in the account during the previous year is Pn minus 2. And so the first dividend, or the second dividend, is 45% of Pn minus 2, which is 0.45 times Pn minus 2. And so, considering the three different cases, we have that Pn can be equal to, well, in the first case, it's just Pn minus 1. And in the second case, we could have just the first dividend, so 0.2 Pn minus 1. In the third case, we have the second dividend, which is 0.45 Pn minus 2. And this can be rewritten as 1.2 Pn minus 1 plus 0.45 Pn minus 2 for n greater than or equal to 2. And we're told that the initial condition is a deposit of $100,000. So P0 is $100,000. And after the first year, we only receive the first dividend, which is 20%. So that P1 is simply going to be the initial deposit, P0, plus 20% of P0, which is 1.2 times P0, or 120000. And so this is our recurrence relation with initial conditions. In part B, we're asked to find how much is in the account after n years if no money has been withdrawn. So we're looking for Pn in terms of n. Well, we have a linear homogeneous recurrence relation, and so our characteristic equation is r squared minus 1.2r minus 0.45r, or 0.45 equals 0. And so we have that r is equal to 3/2, or r is equal to negative 3/10. And since these roots are distinct, the general solution is an equals, well, instead of an, this is Pn, equals alpha 1 3/2 to the n plus alpha 2 times negative 3/10 to the n. And using our initial conditions, we have that 100,000 is equal to, this is P0, so this is alpha 1 plus alpha 2, and we have that 120,000, which is P1. This is equal to 3/2 alpha 1 minus 3/10 alpha 2. And so if we solve this system of equations, we obtain that alpha 2 is equal to 50,000 over 3. And we obtain, by back substitution, that alpha 1 is equal to 250,000 over 3. And so we have the particular solution is Pn equals 250,000 over 3 times 3/2 to the n plus 50,000 over 3 times negative 3/10 to the n.